Now let's look at example 2. A raindrop falls at 3 meters per second. Find its velocity if it falls through a current of air moving horizontally at a speed of 4 meters per second. Now, how do you go about this one? So let's look at this diagram now. So let's OA let's OA represent the velocity of raindrop in still here. Then let OB represent the velocity of current of air. Is that okay? So the one is still here is 3 meters per second. Then the one of a raindrop in is still here is what, 4 meters per second. Is that per second? Now the resultant, that is this velocity now. The resultant velocity field represented by OC here. This is the OC. So then let this theta be the inclination of OC to OA. To what? To OA. So to OA means at least to the raindrop in still here. Is that okay? Now, having said that, so we now have to find phi here. So we can use Pythagoras theorem. We can use what? Pythagoras theorem. Because this one looks like a rectangle, so this angle here must be a right angle. And if here is 3, if OA is 3, then BC must also be 3. Is that okay? Is that okay? Then if OB is 4, AC also must be equal to 4. Now, using Pythagoras theorem now, this is hypotenuse side. Phi, so phi square is equal to 3 square then plus 4 square. So 3 square plus 4 square is equal to 9 plus 16. Then 9 plus 16 is equal to 25. Then if you find the square root of both sides now, so the length or magnitude of phi will be equal to square root of 25 is equal to 5 meters per second. Right? Then to find this angle now, to find the tangent of this angle, so tan theta will be equal to adjacent. Which one? Here is opposite here. AC will be opposite this time around. And we said that if OB is equal to 4, AC also will be equal to 4. So adjacent will be what? 3. So the adjacent is 3, then the opposite is 4. So we now say opposite over adjacent, which is tan. Toa. Soka toa. So the toa tan theta is equal to opposite, which is AC. And AC is equal to 4 because OB is equal to 4 also. Then over adjacent, which is 3. Is that okay? Now to now find the value of theta, so you need to define both sides by tan, and then which is the same thing as arctan. Arctan 4 over 3. So that is the angle here. Is that okay? So that is the angle here. So now the velocity here is what? 5 meters per second. Then the angle, inclination angle here is equal to 4 over 3. Is that clear? Now let's look at another question here. So number 3. We have to find the modulus of resultant of velocity 8 meters per second and 6 meters per second at an angle of 60 degrees. Now, we are given the angle here this time around. The tangent of the angle between these two velocities, 8 and 6 now, is what? 60 degrees. Now, let's look at how the diagram will look like. Because so you cannot have this one straight line because it's angle 60. So if this one is angle 60 degrees, so the first velocity, this one, let's say this one is 6 meters per second, and this one is 8 meters per second. Is that okay? Then incline at angle what? 60 degrees. So we need to draw the resultant here. So let's phi, this velocity, be the resultant of the two velocities, this one and this one. Then here now, to find this phi, we need to use cos rule, which is that this phi square now is equal to, this phi square is equal to c square plus 8 square plus 2 times 6 and 8, then cos this angle. Cos what? This angle. That is the cos rule. Is that okay? Cos rule. Now, what is the value of 6 square? 36. What is the value of 8 square? 64. Then 6 multiplied by 8 is equal to what? 48. Then multiply by, we have 96. Then cos 60 degrees is equal to half. Is that clear? So then half of 96 is equal to 48. 36 plus 64 is equal to 100. 100 plus 48 is equal to 148. Is equal to what? 148. Now to now find the v. To find v, you need to find the square root of both sides. So if I find the square root of phi square, you have phi, that is length of phi, which is magnitude of phi, is equal to, then square root of 148, which is equal to 12.2 meters per second. So here now, the angle is given already, so there is no need for us to find the angle again. Is that clear? So if this one is clear now, I would not like you to look at this question, which is your exercise, and try. So result of 10 meters per second into two perpendicular components such that the components are equal. Then the second one is one component is twice the other. One component is twice the other. So what you need to do here is just draw the diagram. Half one along y-axis like this, half the second one along the x-axis. Then the velocity you use to have in the middle here has been given. So let me show you what I'm saying now. So I think this diagram is like the one we are using. So if you have something like this at O, if this one is OY and this one is OS, right? So at the middle here, just half the velocity. Is that okay? And the velocity is given to be 10 meters per second. So what we are now asked to do is the first one, they say that you should find a component. You should find the two perpendicular components. Since they are perpendicular, you know that what you will form will be in right angle. Then such that the components are equal. So for components to be equal, that means this length from OY to OS must be equal to the same. Must be equal to what? The same. So just use phi cos theta is equal to phi sin theta. Is that okay? Phi cos theta is equal to phi sin theta. And you know the phi is given to be 10 meters per second, right? So you can just make theta the subject of formula. Is that okay? You know your phi, substitute and get it. Is that clear? Then the second one component is twice the other. So for one component to be equal to be twice the other, maybe you say that this OS here, the one, is 2 times OY. 2 times what? OY. Using the same 10 cos theta is equal to 2 times 10 sin theta. Then find it. Is that okay? Find the value of theta. Then you get it. So I think that's all.